Okay, maybe we can start. Some people are still coming, but for the sake of time, we're already a bit behind the schedule. So let's start now this workshop. So the idea behind this workshop is to show a bit some practical demonstrations of how companies are using different tools. Some presentations we'll have for companies providing the tools or for other people to use it. And then some presentations will be about companies using the tools and sharing experiences about that. This is why it's going to be interesting to see both sides. And also, in the way that we have planned these presentations, we'll have first a presentation from PADECASA, which is about how they use these tools in the ASPHALT plant. Then we will have Q-Point to see the logistic tools, let's say, or digital tools for the whole supply chain. Then we will go to the maintenance with XOUBA, and then at the end we will have a presentation from DARS with an app for the road users. So with that, I think we will cover as well all the possible stages of the asphalt pavement. So with that, since we are a bit late, I think we can start. Jorge, you want to start? I will introduce you. Sorry. Okay. Here we have. So Jorge Salas is a postdoctoral researcher with extensive experience in the construction sector and process modeling. He is currently working on a project to create a digital twin of the asphalt mixture manufacturing process for the company PADECASA. Additionally, he is involved in the ASPHALT project developing the data processing application. Right? So Jorge, thank you very much. Show us how you do it in PADECASA.
Okay, thank you very so for your kind presentation and to the organization for the opportunity to show in our work. I'm going to talk about ASPHALT, which is the monitoring system we are developing at PADECASA for monitoring the production process.
Yeah.
Okay, so. Oh. Think about this. Okay. This presentation is structured in two parts. First, I will give a brief overview of our system, and then I will show a case use of its application. The architecture of our system is quite conventional. It's typically used as the bottom layer of any digital twin, and is responsible for gathering data of the real world. This data, in our case, comes from two sources. One is the plant's PLC, and the other one is from a net of sensors connected to a platform through a IO-Link network, which enables, in a very easy way, to gather the information of all the sensors, collect it, and send it to other places. This approach has an advantage, which is that you can deploy your sensoring system without affecting the functioning of the plant. So in case of retrofitting or upgrading plants, it's quite important because it reduces the impact on the production stage. This information goes to a Munoz platform. Munoz is a software for industrial monitoring, which allows visualizing the information and structure the information. For example, in our case, we structure it by parts of the plant. So, for example, the feeding system has its own sensors. The stocks can also be monitored. What is happening in the dryer, the temperatures. For example, these are the temperatures of the dryer, which you can also use later on to fit models and so on. And this was indeed what we are doing in our digital twin. It provides also information about the humidity of your materials and so on in real time. And this, once we have gathered all that information, we send it to an SQL database, which is a very common database language, through a data logger, which is Kep Server X. server X takes information from the Moneo system through a MQTT protocol, which is also quite a standard, sends it to the database, and in the database, we begin processing it. We have developed our own application for associating the information from sensors to the events that happen in the plant, mainly to mixes. So each time a mix is created, the PLC gathers a lot of information, but the sensors do not, because they are not connected. So we must do that work. We do it through our platform, through our application, and this way we also identify deviations from theoretical values. Along with this identification, we have developed a Power BI-based platform which allows deploying the information to each department through a reporting system in order to perform rather quantitative analysis. With the first application, we can develop qualitative analysis in order to find out deviations. With the second one, we can have an overall outlook of the performance of our production system. This we have implemented in 2 plants. And this, we can also find out CO2 emissions, CO2 equivalent emissions at mixes and delivery orders level by type of recipe, and also by discriminating between types of material and sources of energy used to heat the components. So this enables us to develop our own impact, environmental impact system. And this was all about the architecture of our monitoring system. As to how we use it, the use case I'm going to talk about is using it for the identification of deviations from technical requirements. Specifically, we use it for identifying when a delivery order or a truck contains asphalt which could not meet the requirements of our clients in terms of the shape or the aggregates, the sizes of the aggregates within the mix. So at delivery order level, we can identify which delivery orders are out of or may be out of specifications. We do that by plotting the real dose and the theoretical dose of each component, the sand, the other aggregates, the bitumen, and so on. And once we find one potential problem, we look at it more deeply at mixes level, so we can identify exactly which mix could be problematic for us, and then inform to the construction site and leave that part of the truck or even the truck, the complete truck, without laying it, preventing having to spend much more money in the case of identifying further problems when the pavement is already done. And this is the case I wanted to share with you. And if you have any question about it, I will be glad to try to address it during the rest of the workshop. Thank you very much.
Is there any question for Jorge?
No.
I think it's very interesting to see for quality control of what we are delivering, no? That when you detect something, it's always better to say, please don't use this mix or this track or part of the track, as you explained to me yesterday. And maybe it's just like a few €100 that, as you said, but if you put it on the road, will cause a big problem maybe?
Yeah,
or
will have an economic cost and also a more important cost to your image. So the problem with those things is the cost with your client in terms of having to intervene in the road once it is operating and so on.
Yeah, so it's very interesting to see this continuous monitoring with the sensors in the asphalt plant is actually helping to provide a better quality. And also in these readings, in these graphs, you can see also the impact of different materials. It's very interesting to see how the emissions change drastically depending on the mix. It's not the same for a coarse layer than a base layer. If you put cement, suddenly it goes up and down. So it's really nice to see how all these sensors are measuring what we expected, and it's a part of the monitoring of the
and sometimes you have some surprises as to components that have very low percentage in the mix, but on the other hand, they produce they have a very big impact on your mix and on the CO2 emissions, which could point out or give you insight about where you can improve your process. So specifically where, because sometimes you may think that aggregates are more important, and it is not the case.
Right. Yeah. So very interesting, and thank you very much, Jorge. Okay, so let's continue now with Thomas Leopoldseder. Since 2021, he is the CEO of the QPoint Group, a solution provider company for the asphalt industry. In August 2024, he was awarded as CEO of the Year in the area of civil engineering construction software by the international medium EU Business News. This is further proof this is a great commitment to developing the asphalt industry in the sustainable industry. I think many of you already know him because he was presenting yesterday, but here he is again. Thank you, Thomas.
Welcome again from my side. I will show you a little bit about how digital processes can really work in practice. But first of all, I want to know if you're working in a construction industry or in the asphalt production industry, who can say that he's using digital tools on this value chain. And I do not mean WhatsApp, Excel, mobile phones. So who is using partly or at the full value chain digital tools? Okay, 1, 2, 3, 4, okay, 4, 5. Not so many. The question is this a representative thing? But you see here a lot of companies using digital tools, and there are many more in the market that are concentrating and using these tools to support their digital value chain. And that's very important. I think we are not alone in that market. It is used and it's not in the future. It's just working, and we can start today, tomorrow with that solution. I want to show you in a short video how this system will work. So let's imagine we are on the construction and we are a construction manager, and what we have to do when we use digital tools. So the first step, we are the site manager. You see this here, and we have our projects. It's not necessary to be in the construction site. I can sit in the office. I have here my project list of the projects where I'm responsible. I can filter them. I can search for them. I can also mark them as a favorite so that I find them very easily. And then I create my project in a very few things. I enter also the address. This address is supported by Google Maps, so it's easy to locate the construction site. And we can also pass this information from another IT system. So in normal case, it's not necessary to enter that data. You just receive that from a commercial system or SAP system or whatever you're using in your company. Very important is that you can also add graphical information like that here. We enter here a point of interest, which means this is the entry point of the construction, and this is the exit point of the construction. But I do not want to pave this road. I want to do it a little bit more complex, so I can remove these points here, and I will pave this. This is very important for the people working on the construction, but also, for example, for truck drivers which will come later and deliver the asphalt to this construction. So everything is now saved. And the first process I want to support with the solution is not asphalt pavement, it's REP management. Because when we are milling the REP material, it's also necessary to bring it to a REP plant. And we can use the system to enter some information that I will deliver REP material to a recycling plant. So I select here a plant, I select the material I want to deliver, I select the time when the trucks will arrive at the REP plant, and I select also the trucks which will be used in this process. I add a comment, and then I send this to the REP plant. You see here a status, and now we are changing to the recycling plant. We receive this information in a digital way. I can open it, and you see here on the right side, it's very fast, but on the right side you see all the information which have been entered by the client. The REP plant can check if they can accept this material. They will approve it. And you see also the communication with the people on the construction site is done manually. I accept it. And the site manager sees here in the status that this delivery has been accepted. Okay, now we have delivered our REP material. Now we are doing asphalt management. So we do more or less the same thing. We select here an asphalt plant. We select our mixing orders from a menu. So it's not possible to order a wrong material, which is not available on that plant. I select my delivery date and my delivery time, a delivery rate, which means how fast can I bring this asphalt on the road, more or less. I can decide which truck will be used for the transport if this is necessary, and I can also add a very small comment. It's more or less a question to the asphalt plant: can you deliver this asphalt at that time in that quantity? So I'm sending that also to the asphalt plant. I create a second one just to show you that we have two different types of requests. Yeah, here is also a possibility to calculate quantities based on a map, for example, on a plan. You can also predefine the route for the truck, which has to be used to come from the asphalt plant to the construction site. Here is a screenshot of the app. So all this information which have been entered in the web browser are also available on the app, and the foreman can send this prepared order now to the asphalt plant. So we can separate the processes between the construction manager preparing everything and the foreman then changing something or send it in then to the asphalt plant. What we are doing here now. We have two different states I want to explain. One is just a forecast, what will happen in the next week, and the other one is I need this, so we sign more or less a digital contract. So we receive this here on my asphalt plant. I get the same information here on the right side about delivery dates, about the construction, also the phone number, which is maybe sometimes necessary, but it's not necessary to look somewhere. So I enter here also from the plant side some master data about the construction. Also, this data can be passed to the system via interface, and then I accept it is only pressing a button, and then everything is confirmed between the construction manager and the asphalt plant. I can also add a comment, you have seen that. So the whole communication is here organized with these digital tools. So when we are changing back to the construction, we see always the current status of the orders, if they are accepted, if they are not accepted, and the asphalt plant proposes a different delivery date, for example, then we will see also here a message, I cannot deliver, I can deliver in 10 minutes later, and then we have to accept it. I can also change my order, so it's not really fixed. I change now to the quantity to 280, if you have seen, and send it again to the asphalt plant. But what will happen at the asphalt plant? He opens the new request. It's like an inbox in Outlook. And if he opens this request, you see yellow mark the changes. It was 300 tons, now it's 280 tons. And you can go back in the revisions, so you can see what has happened in the first revision, in the second revision, in the third revision. So everything is documented, what has been done in the communication between these two partners, which is a very important point. So I can accept or I can decline or whatever, I can propose a different date, whatever I want to do from the asphalt plant point of view. Now I accept it and then we can start the production. So I receive all these digital things, orders in my planning tool. You see here different recipes which I have to produce. I can move them to the right position if I like to produce them. I can combine a production to one production lot, which is very good to have one production lot to save energy, to avoid changes in the recipe. But I can also split it up if it's necessary to find some dates. In the background, we are calculating automatically a transport plan, so we see which transport should be happen to load this day. We are also integrating the truck driver with an app. He receives the delivery information and he's sending the position of his truck to the asphalt plant and the construction manager. So the construction manager sees when the truck will arrive on the construction site to prepare the work. And on the other side, you see here it will arrive at 10:56, for example. And on the other side, we are also sending that information to the asphalt plant to see when the truck will return to the asphalt plant. During the whole workflow, we are collecting a lot of data. I've also reported something yesterday about energy consumption, about the orders, about all these things. So when we are now in the paving stage, we are supporting the machines by a retrofit system. So we mount the system, the sensors, the GPS systems on the machines, any kind of machine, which guarantees that the accuracy is the same, that the sensor type is the same. We measure the sensors, the surface temperature, we measure the weather temperature, weather conditions, and we measure also during the compaction process with sensors the temperature, also the passes, also the stiffness if it's necessary and if it's possible, depending on the type. We are visualizing that for the drivers, so they see what they are doing based on a target value which has to be gained. And then in the background, we create a lot of statistics and things where you can analyze what has happened in the construction. You see here a small simulation where 3 pavers and a lot of rollers are working on the construction. The whole system is also online, so a quality manager can sit in the office and see what is happening on the construction site. My colleague in Spain has a presentation at the moment, and I'm connected to this presentation and see exactly which demo example he is showing to our possible clients in Spain. So the point is, you can manage the production, you can manage your asphalt plant, you can manage your constructions from any point, from any place, at any time. And I think this is more or less the largest benefit we can have. We are collecting a lot of data to optimize the processes, and that's a real digital value chain. Thank you for your attention.
Question for Thomas? I think it's very interesting to see how these tools make the whole supply chain so dynamic, and we can readjust everything in real time, and so user friendly as well, and even helping then for all the documentation and everything, all the administrative work. So I think it's great. If there are no questions for Thomas, then we move to the next step. That is, once we deliver the road, what happens next with the maintenance and so we come back to Miguel. Thank you, Thomas. So I don't think I need to present again Miguel. It's the third time in 2 days that gets on the stage. I think we need to do some, you know how to do it, or we need a technician?
Let me see.
Miguel is going to do a live demonstration of how he uses
the first mistake that you don't have to do in a presentation is doing live. Okay. Okay, so just an hour ago I tell you what are we doing. So now I'm gonna show you what is actually the work that we do. Well, we are gonna show what is Naira. Naira is one of our suppliers. It's a Volkswagen Group, one of the biggest suppliers of cars in Europe and on the world. And what we were talking about, that the M50 was repaved, we're gonna see the effect of the repavement that they don't even know. They finished like 25 days prior to the Congress. So let's see. This is a visor where you have blue, where is that you repave, the IRI is improved, and the red parts that is getting worse really fast. So when you look at a place, maybe it's too small, but let me show you. This is the IRI. It's per day. We can go back like, I think that we have 12 months in the visor. And here you can see that it goes down from 2.5 to 1.1. So who is collecting this data? All of us. I hope that you go to Spain to go through the M50 and you will make some data for the supplier. And this is the effect of the connected car. You don't have to measure anything like we were discussing before. If you want to do a deeper analysis, there are other technologies to do it, but this is the way to make the whole network as we're gonna show. Okay, Miguel, this is really cool, but let me show you something cooler, I think. This is the IRI of that part. As you can see, there are plenty of roads, plenty of ramps, plenty of streets also. So there is a focus only on the highways that we have here, and the place that we were looking, it was around here. So first of all, I want to show you, this is the average days since last measurement update. It's completely 0, so it's actual. You don't have to go there to measure anything. It comes from yesterday, so tomorrow we will be update today's data. So let's see what is the effect of the repavement. In the x-axis, you're gonna see like there are segments like around 25 meters. That's the accuracy that they are providing right now. Okay, so we can know exactly when they did the measurement. It was August last week. I'm not there to look at what are they working on it, but the cars are telling the truth. That's the good possibility of the connected car, that they are giving you the information. So now we have 1.43. You don't have to go to measure. Another good thing that, for example, we can look from here is something so easy as the weather. What is the weather right now at 11:15 in Madrid, in that part? It's 18 degrees. We are here in Slovenia, a little bit colder than that, and we can see what is the temperature of the cars that are going through the road. Also, we have the wipers, if it's raining or not. right now, let's see if it's raining. It's wiper off. Okay, Madrid is, I hope, sunny. When we get back to Madrid, it will be sunny. We can go back to see if it was raining. The wiper was on here, a group of wipers. Maybe there was something over there. And that's the powerful thing that we have on the cloud, all the data. We can ask, and this is like only the user interface. You cannot make, let me look to that, like engineers who speak in that road, in that kilometer marker, and you cannot do that. You have to make some analysis. So we create some dashboards. This is 81,000, almost 82,000 kilometers of a second level network in Spain. Nobody asks for us to do it, but we like to do analysis. And then we have the province of Madrid, Andalucía, Aragon, and we can see how it changed the IRI from one to the other year. That's the good part. We're not doing every day. It doesn't make sense to do it every day, once a year. So sadly, we can see that it gets worse, 80% in the whole network, but we can go deeper in the analysis. We know the kilometer when it's worse, the even 25 meters where it's getting worse. We can see only the single carriageway, dual carriageway. We can make plenty of hope answers to the question that the road authorities has. We can go deeper, for example, in Andalucía, that I recommend you to go to holidays. For example, the IRI, the average of the whole network is 2.7. Okay, that's not really bad, depending of the type of the network. In 2022, it was 2.3, so it's 14% worse. Okay, let's see the ones who improved last year. What does it mean improved? That you repaved. Those are the roads that were repaved last year in Andalucía. I didn't know anything about Andalucía. I've never been there in those roads. I don't call anybody to know that. And this is the thing powerful to this technology. That is only an example that we're doing right now. We make a lot of things, for example, for city councils. You need to repave that street because it's getting really worse. Or I know that last week you repaved those streets. We have plenty of options. Also, with that, I'm gonna show you another thing that we have is the potholes or the bumps. Let's start with the bumps. Here is really small maybe, but you can see there is one thing that is first time that it was detected and last time it was detected. Here says 0 hours. So there was a car passing through that bump that is really close to my, no, that knows the location. It's a park and there is a bump to reduce the speed. The cars are making the information for you. Also, let's go the other way around. We have the places, for example, this one, 0 hours, where there is a pothole. I was looking just here in Google Maps, and there is a pothole over there. So that's the good thing. You don't, let's connect. Here is a pothole. This is really close to my office, so that's what I know and I can show you. But you can make it in all the network. That's the good thing. If we go to Madrid, it's gonna get crazy. Plenty of pothole. We need money to make investment. And this is the good part. I can go everywhere if there are cars connected to the system, to the cloud. There are too many potholes in Madrid area. So that's the thing that we want to show you. There are plenty of use cases. We are doing only the top ones, but we want to go deeper in that analysis with fuel consumption, with roughness, with speeds, with any sensor that your car is giving information. And that's a really, I don't have information for Slovenia, but if any of the Spanish guys want to know anything about their streets, I will show you and you can complain to your mayor. So that's a good part. That's the way to act with data. We were wondering, no, my road is bad. It's really bad, and it's getting worse. It's going to cost us plenty of money next year if we don't act right now. So that's it. I have plenty of options to show you, but I'm not going to get bored of showing you around. Thank you.
Okay, thank you, Miguel. Any question?
You get the data from the car, for example, about the pothole, but it would be theoretically be possible to give the data back to the car. Pay attention. There's a pothole.
Yes, yes. Technically, they are doing it with the autonomous driving is what they are gonna send. Actually, for now they aren't doing it, but for example, I'm not gonna say you the supplier that is gonna do it, but when a car detects a pothole, the next of that brand is gonna take a picture. So you will have everything of the pothole.
I'm thinking about security.
Yeah.
So that the others don't crack in the same pothole.
Absolutely. Or with friction, or with any signal, whatever.
You can even know if it's raining 1 kilometer ahead because the wipers. So you start moving the wipers. Maybe. I think it's also a very transparent tool because you are monitoring the whole network, and it's not about the city hall going there or not, or deciding not to go there to see. The whole road network is monitored, and you can know what sections are green or yellow or orange or red. So it's a very good way to say, okay, we establish the threshold in everything has to be green or yellow, but whatever is red or orange, we have to do something. And so for the management, for the asset management, I think it's a very interesting tool because it's everywhere and it's real time, it's monitored, and you don't even have to send anyone, as you just said. So it's, to me, the first time I saw this kind of, these presentations from XOUBA, it looks like science fiction, but it's already there. And I think it's very interesting. Jorge.
Only for general information, but I think it's a very interesting thing. In Spain, we made each year a space of alarm. Alarm is, as you know, is made by the English Association, is to give a general overview about the state of the roads, in particular in England, in UK. Well, in Spain, we do, until this year, we made analogically. A guy walking, seeing, taking notes, and finally giving the information. And was a very important element because give a general overview of the roads, but based on analogical procedure. And we push, several people push on to change the way. And thanks to this technology, Asociación Española de la Carretera is the national Spanish association, will be made this year the same work, but based on this technology. It's totally different because first thing, we analyze on the precedent years 500 length of 200 meters walking. It's a lot of work, but nothing in comparison of the total network. And now we have all the possibility, all the information, and on-site, on real time. And it's a very good thing. Thank you.
I think this could be even information for the citizens, but to know exactly what your administration is doing, because sometimes they promise or sometimes they say, we did, but with this it's obvious how, okay, so how was last year? You were showing different regions of Spain. I was paying attention if my region was better than Madrid or not. So you can actually see how effective the investment is being and what are they doing. And so I think it's, and it comes from the users themselves, from the cars. So great. Thank you very much, Miguel, once again. I don't know if you have more presentations.
No, I'm finished.
Okay. And our last speaker is Brane Nastran. We had a last-minute change in the speaker from DARS. Brane, if you can introduce yourself and then just proceed.
Thanks. Welcome. this was a good starting point how to put all this data to users, and this is our job. I am head of Traffic Information Center in the motorway company in the Republic of Slovenia, so we are dealing with these things like I will introduce just one tool that we have also for our work, and it's also for drivers. It's our mobile app that you can use, or please use it when you drive on Slovenian roads. We will just see a short movie if it will start. Yeah, just how it works. A brief overview, and it's also you will see how we tested it, how we developed it with a driving simulator. Just a few. Just what we are doing here is that we wanted to test and assess how to use it in the car, because it's not very safe to do anything besides driving. So we had a driving simulator, and we tested how the drivers react when the messages, like when they get voice message, when they get a text message, when they get only a picture or a sign or something. And also, it's also important where the message stands on your device. Is it low? Is it high? Or where it is? So this was developed with this all these tools. And what we are doing here is that we want to connect, because we are dependent on all the systems that our motorway company and also the roads agency they use for their work. Also, the tools that you presented before. These are always a good source for valuable information for the drivers. So what we do is, all the time that we are planning and thinking what to and how to push it to the drivers. And one important thing is that well, okay, no problem. We tested in the driving simulator the usage, and we proved what we all know, that the good informed driver is a good no, it won't go away. Narobe ki pritiskam.
Wait.
Okay. This is what we proved, that we are more satisfied when we know what's going on the road, and we are also driving more safely. These are some screenshots how the application works. if you use it, we connected it with the website, promed.si, if you drive, or if you need to know anything about the road network or what's going on the roads in Slovenia, you use this website and you can connect your app with this website and then use web where you're in the car. This is what I was talking about. It's not, the role of this app is not only, though it's very important for the drivers to use it so the roads can be safer and the drivers better informed. We also put it, we developed it. Some people asked us, why develop the app like this when you have all the commercial providers like Google, like here, like TomTom, or any other apps, ways people use? Well, it is our job to give the information to the drivers that drive in Slovenian roads, and we found out that they don't give all the information that we produce and that is needed, to our opinion, that the drivers would be really good informed. And since they don't do it, we do it with our systems. This application is, in fact, only one stretch of the background system, that is a system for traffic information services, and we provide a lot of other things, and this is all. We have also tools for our people in traffic management centers, in traffic information center, to use that application, and from that application we is a source for also the app, a mobile app. At the end, you can see the CITS. We used this app as a CITS tool for testing cooperative intelligent transport systems. As you know, there is a European project, C-Roads, and we are very active in that project. And we tested with that app also these systems. And what we do now relating to maintenance of the motorways and related to reconstruction of the motorways and all roadworks that are necessary on the roads, we connected this app to the devices on the maintenance vehicles, and we get the information directly to our system and through our system to our app, and we use these CITS systems that we developed. That information can be also, it's not that any data that comes, that's quite a big difference for us between data and information, because we have a lot of data, and you can, if you give too much data to the driver, it's opposite of safety. So we have to translate it to a good information. So our CITS systems are very good in that, but you need experts behind. You need people that know what they are doing. So my stress is always have a good experts that can do it maybe manually, but they can develop. They are the best developers for our tools. And we develop this also with our operational people in traffic management centers, traffic information center, in connection with the drivers, and in connection with maintenance workers, because they can provide us a good information what to use, what could be useful for the drivers when they are going on the road and do something on the road. This is just a scheme about how our CITS hybrid system works and where the information comes from. And also we get, on this app, we can get also information from roadside units, from CITS systems, from microwave communication. Via hybrid system, we get in less than in seconds, we get good information to our app, and you will get it on the road when if you are on the motorway. This is one case. on Slovenian motorways, we have quite a lot of loops, inductive loops. And these inductive loops are managed that they can also alarm the wrong way driving. If somebody drives wrong way on that loops on motorways, they trigger the alarm, and the alarm goes to our hybrid system and directly to the app. And our app knows where you are, and if you are driving on the motorway that you are in the danger of this possible wrong way driving, you get an alarm on the app, and you get a voice alarm, so you don't have to look at your app. You just have to be careful how do you drive along this road. So, and this is just a proof of concept that we just made, and this is development for the future. We made a proof of concept already to put this app into Android Auto, also to Apple CarPlay, but there are some issues, more administrative than technical issues with Apple, but this is how we want to go on to, because we are living in this media world that there is more and more tools that people use, and they are more diverse, and we have to deal with everyone. The old tools haven't died. A radio is still there. Phone is still there. They are still calling. People are still wanting information by calling center or somebody. But there are new tools. There are navigation systems. There are CITS systems in the cars. There is like Android Auto. So we have to cover. We need to cover all the things. And to be good in these things, it's not just that we know how technologies work, digital technologies work in this field, but we also need to have a good cooperation and very close cooperation with all the people that are working with roads, on the roads, and producing all applications and producing all the data that we can use to go on. And use it if you're there, so you will drive safely. Thanks.
Okay, thank you very much for this last presentation of the workshop. Any question before we close? Or comment? No? In that case, I guess everything was very clear. So thank you everybody for coming to this workshop, and enjoy the break.